Hey guys, it's Miss Richardson here. This video is for Wednesday, January 11th. I am out of the office today, so I will be back tomorrow. So I went ahead and made you this video, and the good thing about today's lesson is it's probably the easiest lesson we'll have all year. Yay! So watch the video all the way through the end, and when you're done, you will be an expert on cross sections. So what are cross sections? So we have all of these three-dimensional blue figures on the screen here. So these two are both rectangular based pyramids. These are both rectangular prisms. Here we have a cylinder, and this is a pentagonal prism. So you name them by the base. So the base of this is a pentagon. The base of these, you could call these either squares or rectangles. The base of this figure, this pyramid, is a rectangle. And then depending on what the sides of it is, it's either a prism or it's either a prism or a pyramid or a cone or a cylinder. So those are the ones we're going to be messing with. All right, so if you take a three-dimensional figure, so I found this jar in my office here at home, and imagine that this thing is solid. And did I say cone? This is a cylinder. I don't know what I said. Anyway, you take this cylinder and pretend it's solid, and I cut it vertically. So if I cut it vertically, that means I'm cutting it perpendicular to its base. So perpendicular lines form a 90-degree angle. So if I cut this perpendicular to its base and I open it and look at it, I'm going to see a rectangle. Can you imagine? The two-dimensional figure is going to create as a rectangle. What if I take this cylinder and I cut it parallel to its base? So a parallel to its base, so parallel lines go this way, right? Also, you would call that a horizontal cut, right? Going this way. If I cut this horizontally and I opened it, what I'm going to see is the shape of the bottom, the base, which is a perfect circle, okay? So taking a three-dimensional figure and slicing it either perpendicularly or parallel, which is horizontally, that creates a cross section. So that's what we're talking about today. Here is our standard of excellence. These are our learning targets. And if you don't remember how to name three-dimensional shapes, watch this cute little video. You'll be singing this song in your head for the rest of the day if you do. It's embedded in the slide deck. Just some vocabulary terms you've learned in the past. These are the edges of a three-dimensional figure. The corners are called the vertex. We have the face, which goes around the figure, and then the base is the top and bottom. All right, here's some vocabulary terms that you have known from your past. So go ahead and read those. So when we talk about slicing an item with a plane, we're not talking about one of these planes. We're talking about a flat surface that could go on and on forever in all directions. All right, so like I was talking about, there's different types of cross sections. We're going to really focus on the vertical slice, and we're going to focus on the horizontal slice. Of course, you could do any kind of angled cut you want, but we're just going to focus on the perpendicular cuts up and down and our parallel cuts. So this is a rectangular pyramid. It's showing that this thing has been cut three different ways. And we're going to look at their cross sections. All right, so here we have a cone. So imagine a cone sitting with the open part of the cone down. Well, either way, if you cut it parallel to its base, so a horizontal cut, what you're going to see is a circle. Now, it's hard to show a three-dimensional figure on a two-dimensional surface like your screen. So even though that looks like an oval, just like my cylinder here, if I turn this and show you the bottom, you can see that it is a circle. So anytime you have a cylinder or a cone and it's going to be cut horizontally, you're going to get a perfect circle. All right. What if you put this cone back together and then you slice it right down the center and pretend it's solid, and you open that cone after you have sliced it? What are you going to see? This will be a triangle, right? A triangle. Now, if we have look at this pyramid right here. If we have a rectangular based pyramid, whether we slice it horizontally in the middle or even toward the top, it's going to look like its base. So we would find a rectangle. Any kind of prism, same thing. It's going to look, the cross section is going to look like the base, which is a rectangle. And then here's our cylinder, cutting it parallel to its base. If you open it and look at it, you're going to see a circle. If you cut it straight down the middle in a perpendicular fashion and open it, you're going to see a long rectangle. All right, you can come back if you need to and look at this quick video. It's entertaining as well. Like I said, if a 3D shape is cut parallel to its base, like this picture here, then the cross section looks just like the base. Think a stack of cheese or a stack of CDs. If a 3D shape is cut perpendicular to its base, then the cross section looks like the lateral face. So what are the sides of this pyramid? They are triangles. So if we cut it down the center, perpendicular to its base, you're going to see a triangle. And we're not going to worry about the diagonal cuts. We're not going to worry about that. All right, so this is like a big block of cheese. This is a triangular prism. This is a triangular prism. So since the base of this is a triangle, if we cut it parallel to its base, we're going to have that triangle. All right, here, our rectangular prism, we're going to look at the base. If we cut it perpendicular to, parallel, get my words mixed up, parallel to its base, we're going to see that base, which is a rectangle. All right, here's our cylinder. If we cut it perpendicular to its base, we're going to see a rectangle. And our cone, if we cut it perpendicular to its base, we're going to see a triangle. All right, so these are all going to be the same. So guys, this whole lesson, I'm pretty much repeating myself. So what I used to do when I had students in a classroom is they would bring in Play-Doh and we would make these shapes, and then we take dental floss and we would actually cut the shapes and we'd open it and we could look at it. So that was kind of fun. That was a good activity. However, I encourage you guys to do that. You can build your own figures with Play-Doh, and you can cut those with dental floss, and then you can actually see these cross sections. But really what I'm going to get to, and the thing you need to know about a sphere, so imagine a basketball, right? Does it matter how you cut it? It's always going to be a circle no matter what. So it looks on this two-dimensional flat surface, it looks like we're getting an oval, or another word for oval is ellipse, but we're not. So imagine holding a basketball that's perfectly round. Any way you cut a basketball or a sphere, you're going to get a circle. That's the cross section. A triangular pyramid, the base is triangle and all the sides are triangles. So whether you cut the triangular pyramid perpendicular to its base or parallel to its base, you're going to get a triangle. All righty. So I'm trying to get to the part, and here you can see those cross sections. Here's our triangle. When you cut a rectangular pyramid perpendicular to its base, you can see this red rectangle if you cut it parallel to its base. So I'm trying to get to this one graph. This is it right here. These are all the shapes that you will get. These are the cross sections. So if you are asked any questions about cross sections, they're going to be listed on this page. And these are going to be their what you get when you slice them. Okay, so cylinders, if you cut it parallel to its base, you get a circle. Perpendicular to its base, up and down, you get a rectangle. A cone, it's always going to give you a circle, and a vertical cut's going to give you a triangle. A sphere, you can't ever get anything out of it but a circle. Okay, rectangular pyramid, the base, parallel to its base, is a rectangle. If you cut it up and down vertically, you're going to see that triangle. Triangular pyramid, the only thing you get from it is a triangle. A rectangular prism, the only thing you can get out of a rectangular prism is a rectangle. And then that triangular prism, if it's laying down on its base, if the triangle is on the bottom, right? If you're cutting it parallel to that base, you're going to see the base of a triangle. If you cut it the other way, perpendicular to its base, you see your rectangle. All right, guys, that's it. I'm telling you, it's the same stuff over and over. So here are some questions. Pause the video. Look at how it's being cut. And I want you to tell me what the cut is, and then turn the video back on and check your answers. All right, what about this cone? What'd you guys get? A circle. This is a triangular pyramid. You can only get a triangle from that. A rectangular prism. You can only get a rectangle from that. A cone, if you cut it perpendicular to its base, you get a triangle. Now this is actually a square-based, a square prism, not rectangular. So it's going to be very specific. I would never guess square unless there is a word square in the title of the figure. I'd always say rectangle. And then this is another triangular-based pyramid. You can get nothing but a triangle from it. And a sphere, you're never going to get any figure from it except a circle. Okie dokie, guys, that's it. Isn't that so easy? And this slide deck kind of gives you a cheat sheet anyway, that this chart here, what I was referring to earlier. So I don't think you guys will have any problems with today's or tomorrow's lesson, and also next Monday. Monday's a holiday, so Tuesday you have another activity on Delta Math about cross sections. So I think you guys will do great on those. So everybody have a great day, and I will check in with you guys tomorrow. Bye-bye.